Okay, move on to the final speaker, who's me. And I've saved some small amount of time for myself because when it comes to thoughts on communication, it's not possible to have a lot of thoughts since we have never received a communication. And our efforts to send communications from them as we have learned a little, and I'll pass on my vast experience in this, the upshot of my past experience in this field. First, there's two kinds of communication. One is what you say to the extraterrestrials, and the other is what would be your response to a message from them. When it comes to a response to a message from extraterrestrials, that is a question that's asked every time I'm interviewed. If you got a message, what would you say? And Catherine answered the question in her presentation, and I think she's probably running it too. The right answer is a two-word sentence. It depends. It depends entirely on what you get. There's no way you can plan in advance what's a reasonable, workable, understandable message to an extraterrestrial so you know something about them. My own opinion is the first message we will get from extraterrestrials, I think the probability is 90%, I'm right on this, is a message from which we cannot extract information, either because there is none there, or because the signal-to-noise ratio, we're radio astronomers, we know that's always a problem. The signal-to-noise ratio is too low to extract the information from the message. In fact, I think it's very likely one of the first message we get will be a radar signal, which is a series of pulses, from which you learn nothing except they exist. But that is really big news, and we should keep that in mind. That's not a disappointment. The fact that there is a second civilization in space is very big news, because if there's another one, there's many, many, many more. Nevertheless, we would have this. What would we do? And this question came up earlier. You would march proudly to the NSF or NASA and say, we can build a telescope big enough to get the information if you give us perhaps $100 billion. And they would have their checkbook out, or at least the Congress would soon have their checkbook out right away. Because clearly, learning from another civilization is going to be worth more than almost any reasonable cost to build the equipment to capture signals that will inform you. So that, when it comes to responding to a detection, you're not going to respond right away because you won't know enough. You may have to spend a great deal of time, a year or 2 years, 3 years, building a telescope large enough to get information. You'll know it's there to be found. And you can make further observations and find the faint signals that, if amplified, will tell you about them, and that'll be the name of the game. So no message to be worried about. A lot of electronic technology to be worried about. That's what will happen then. Now, what about when you send messages? And we've sent a number. We've sent the Pioneer plaque. We've sent two Pioneer plaques, 2 Voyager records, the Arecibo message, about which I now hope there is a statute of limitations. It's been 16,
36 years.
I think you're okay, Frank.
It was 74, 26 and 10, 36 years.
Just don't admit anything on camera here.
We should turn off their cameras.
Right.
We should turn the cameras off. Otherwise, I'm going to go camp out here in the forest. I've been there before. It's really nice out there. Anyway, those are the messages we've been sent. We also sent experimental message early on using the same coding technique as was used in the Voyager message, which is to use a raster scan where the number of bits on the axes of the raster are prime numbers. This turns out to be an extremely good way to send two-dimensional pictures because the presence of the prime numbers limit the options as to how you decode the message. And in fact, when I teach courses on this subject, I always discuss this subject, and I always tell them how do you decode the message, and I put one on the final exam, and they always decode it, and that's turns out to be the easiest question. You know, they've got 2 hours to do the exam if they get the message right away, and away we go. Anyway, we learned early on, first we recognized early on that using language is not going to work. Sending them messages in English or what have you is not going to work. Not until you've gone to enormous effort to teach them language the way you do a baby. Show them pictures of things and tell them the name. You know, in some with some symbols that you can use in later messages. But that's very time-consuming and bit-consuming, if you will. What works immediately is, we believe, is the use of pictures. Two-dimensional pictures should work well, although people have challenged this, rightly so, on with the argument that perhaps not all intelligent creatures can deal with two-dimensional pictures. Three-dimensional pictures are better, by the way. You could again use the binary or the prime numbers to identify them as three-dimensional. And my idea there, which I've been running up the flagpole for years, is that probably the optimum interstellar message is holograms, moving holograms. If you have enough bandwidth, enough bit capacity, you can send moving holograms, and this is a way of really describing your culture and how your creatures move and everything, how they live very clearly and in a way that will excite them as well as inform them. We've never made a three-dimensional hologram as a test case, but I think that's something we should do. Recently, with the advent of three-dimensional movies, I wondered if that is in fact a more efficient coding method, and that's something that needs to be looked into. Do you really send holograms, or do you send 3D movie versions of things? Anyway, to evade the language problem, pictures work. And when you arrive at that, you have to think about that some more. And it turns out when you experiment with pictures, you find out you must not crowd them too much. When you use pictures, you usually put elements such as a picture of image of a human next to the image of the solar system or something to show relationships. This is a way of getting a huge amount of information in a picture that exceeds Shannon's limits, because it's just putting things in relationships can impart very detailed information without using a single bit, just from placement. So that's an interesting game to play, which we do in all our messages. Keep it simple. If it's very complex, then you really have to be careful to separate things so that the viewer will not be confused as to what's related to what in the picture. In our some of the earliest messages, we violated these rules. We had things crowded together, and I sent them out. I used to send them as test cases to smart people. I remember the first message I made up, which was a two-dimensional, very crowded picture. I sent to Richard Feynman, who got really, really obsessed with this thing. He was not going to be defeated. He was going to decode it. It was actually a picture of a human and some basic chemistry and such, crude drawings of atoms and such. He came back with a decryption, which he said, "Oh, I worked so hard on this, and it just doesn't quite work, and I just don't know what to do. But I did, I think, find the quantum numbers that describe the iron atom in it." That's what can go wrong. And actually, this is the thing we've learned more than anything in our interstellar messages, particularly when it came to the Pioneer plaque and the Voyager record. And that is the danger with pictures. The thing that can go wrong, and John can attest to this, is ambiguity. Remember, you're sending this picture to, I try those on people too, and I say, try to imagine you're a 14-legged spider and you're looking at this. What would you make of it? what would you think this thing is? And that's where trouble can occur. For instance, on the Pioneer plaque, the man on the plaque is holding his hand like this. Well, we thought that was a sign of greeting, but people point out, that looks like maybe to me a sign of aggression. We're threatening to attack them. So that was bad. We made a mistake there. On the Voyager record, in retrospect, after, well, let's apologize in advance. John and I did most of this. We worked really hard to get pictures which we thought would be rich in information about our civilization. There are 115 pictures of television quality on the Voyager records. And we made the mistake in many of our pictures of using crowded pictures, because crowding ends up making ambiguities for you. There's one picture, for instance, which shows shepherds herding sheep. You show that to a 14-legged spider, and they're going to scratch their heads and say, well, which ones are the intelligent creatures? The ones with the white coats or the ones with the stick? You know, it's and that particular sequence has one picture which we thought was the best picture in the whole sequence until we thought it through. And this was a picture which shows the 60-yard, 60-meter dash in the Olympics. And there are 4 runners. It's the final race. And we thought this picture was wonderful because it showed we had athletics, that we had a spectator sport, and also each one of the runners was a different race. And it showed, therefore, there were at least 4 races on Earth. So this picture had all kinds of important information about us. And we thought it was just wonderful, until it was pointed out to us that with each of the 4 runners, their legs were being held in such a position that with one leg, you could not see the lower half of their leg. They all looked to be one-legged. And, you know, so the thought, what are the extraterrestrials going to think? The people who do the racing are the one-legged ones. It's a one-legged species as well as a two-legged species on this planet. But to make it worse, every one of the runners was not touching the ground. Their feet were about 4 inches off the ground. So not only did they only have one leg, but they had accomplished anti-gravity on this planet. And so 24,000 years from now, when this, well, no, the Voyager record is not that, that's the Arecibo message. Whoever captures the Voyager record is going to lead to a whole lot of PhD theses and such on the deep significance of this, this achievement or whatever it is in this race to have 2 sentient species with this odd physiology. So, anyway, that's my main things I can tell you. Always look at something and say, what mistake could a person make in looking at this thing? And a picture, a diagram, which could otherwise be a very good one, may have to be discarded because it's ambiguous. Ambiguity is the toughest thing to deal with, and that's probably news to you, but it wouldn't be if you had ever been in this business. And I think I'll stop there because it's dinner time, right?